Today, let us analyze the bar element using an ANSYS workbench. Okay, this is the problem. Given a bar as shown in figure is subjected to an axial load of 200 kilonewton at a point P. Calculate the nodal displacement and the element stress. Here we can see a bar element. We are having two elements in this one. This is the first element, second element. The length of the first element is 300 mm and length of the second element is 400 mm. And we have a three number of nodes here. This is node number 1, node number 2 and node number 3. First node as well as the third node is fixed, whereas in the second node the load of 200 kilonewton is applied. And we have a diameter. The diameter of the first element is 55 mm and diameter of the second element is 27.5 mm, and the Young's modulus of the first element is given as 70 into 10 to the power of 9 Pascal, and second element Young's modulus is 200 into 10 to the power of 9 Pascal. Okay, let us analyze this using an ANSYS workbench. The first step in ANSYS Workbench, first we'll go to static structural. In static structural, go to the engineering data. Okay, in engineering data, right click, we'll get edit option, edit. And here we have two materials here. Here we have click here to add a new material. Let us add material 1. Hit enter. And again here it is an isotropic element. So select this one, drag. So now enter the Young's modulus. Young's modulus is 70 E9. 70 E9. The Poisson's ratio is 0.3. Now similarly we have to add the another material number 2. I'll add a material Ma2, material 2, enter, and again it is isotropic element, select, drag, and material 2 is 200 E9 and the Poisson's ratio is 0.3. And this completes the first step. Next, go to the project. In project, next go to geometry. In geometry, select new design modular geometry. Here we have a static structural. Here we have XY plane. XY plane, select right click, look at. So you can see that you have a X and Y coordinates. Change the units to mm, units millimeter. After this, go to the sketching. In sketching, draw a line. Here from first, draw a straight line. After this, go to the dimensions. In dimension general and measure the length of this one. The length of the first element is 300 mm. Now substitute as 300 mm, give enter and give generate. Next, again go to the sketch number 2, select sketch 2, and we have to go to sketching. Sketch 2 here, draw. Again you should draw a line from this second node. I'll draw a line. It's a line. After this, go to the dimensions. Same. In dimensions, we have a general and give the length of this one. The length of the second element is 400 mm. Give enter and give generate. This completes the sketching. Next, go to the concept. In concept line from sketches, select the first line and give apply. Give apply, generate. Similarly, again concept line from sketches, select the second line. Here you have to add a material. You have to select the add frozen and now you give apply and give generate, so that you can see that here two parts and two bodies is created. After this, go to the concepts. In concept, we have to give the area, cross section. I'll take cross section, it is a circular area, so I'll take the circular. And here the first element diameter is given as 55 mm, so that the radius is 27.5. 27.5, enter and give generate. Similarly, again go to the concept, cross section, circular, and again we have to give the second circular cross section. The diameter is given as 27.5, the radius is 13.75. Give enter and generate. Now two circular cross sections of the radius 27.5 and 13.75 is created. After this, go to the select here two parts and two bodies. Here you have a line body, two line bodies, and you have to select the line body. In line body, you should select as a circular 1, and again in line body, you should select as circular 2. To search circular 2 and give generate. It will be created. After this, you select the line body and again press Control. You will select the 2 and give form new part, and new part is created. Now generate. This completes the second step. Next, you have to go to the third step. Here we have a modeling. So the third step is modeling. Select this one, modeling. In modeling, go to edit option. In modeling, go to geometry. In geometry part, line body. Here you have to select the line body as material 1. Similarly, go to line body 2 and again assignment material 2. After this step, go to the mesh, right click, generate mesh. Now you can see that the mesh is been generated here. Okay. After this, go to the static structural display, and display select eye cross section. So you can see the bar element here. Okay. After this step, we have to apply the loads. Okay, here you can see that in the figure we have a 3 number of nodes, and first and the third node is fixed, and whereas in the second node we are applying the load of 200 kilo Newton. Okay, now what I'll do here is I'll select static structural. I'll go to the environment. In environment, I have to fix the first node as well as the third node. Now fixed, and select the vertex. We are applying at the vertex. So select the first node and give apply, so that the displacement or fix the first node is been fixed here. Similarly, go to the third node, fixed and give. Now go to the fixed, and now you can see that the third node is also fixed. After this, you have to apply the force. Force is applied at the node number 2. So I'll go to the force. In the force, you have to select the components here. That is very important. You have to select the components. The components, we are applying the load in the x direction, that is 200 kilonewton. So I'll take it as 200 E3. 200 E3. Select the vertex where you are applying the load, and now give apply, so that you can see that in the x-axis we are applying the load of 200 kilonewton. If you want to see the wherever the boundary conditions is applied, go to static structure. You can see that the first node is been fixed, third node is been fixed, and the second node we are applying a load of 200 kilonewton. After this, static structural solve command. Operate a solve command. After this step, we should go to the solution. In a solution, insert. Solution, insert. In a solution, go to insert, beam tool, and select a beam tool. In beam tool, you can see direct stress, minimum, and the maximum combined stress. Before that, go to the solution, evaluate all results. You should type evaluate all results, direct stress. You can see that this is the result where the direct stress, we have a maximum stress. The maximum stress is 5.48 into 10 to the power of 7 is the maximum stress Pascal, minus 1.175 into 10 to the power of 8 is the minimum stress. Okay, you can see here this is the maximum, minimum. And if you want to check for the displacement, in the displacement, go to the insert, beam tool, insert deformation. The deformation, you can see I have two types of deformation, total deformation as well as the direct deformation. So you can select that one. Similarly, insert deformation directional. Okay, now similarly solution, evaluate all results. Now we can check what is the total deformation. You can see that the total deformation is 0.00023511 meter, and this is 0 is the minimum. This is a directional as well as the total deformation. And we can analyze the given bar element and can determine the value of maximum stress, minimum stress, and deformation. Okay. And also we can see here what is the direct stress value. We can see here what is the direct stress, minimum stress as well as the maximum stress, and also we'll get the value of total deformation and the directional deformation. This is the procedure to be followed in order to solve the problems in bar element using an ANSYS workbench. Okay. Thank you.